Dear aspirants, welcome to my channel. This is a model question paper 1 applied electronics. Okay, so remaining 5 question I am going to upload. Explain the significance of operating point or Q point in a CE common emitter amplifier, how it affect the amplifier performance. So before going to that, what do you meant by point operating point? Okay, Q set point, Q point. Based on this point, the transistor which operate, there is no input signal is applied. Okay. So here we have to use specified the values. We have to collector current. Okay. Next will be an collector emitter voltage, that we call it as an collector current and collector emitter. Based on this, the transistor which transistor characteristics going to active the region of transistor characteristics. So what are the importance of Q point in a CE amplifier? The first point is it is ensure a proper amplification. It means, see, if you keep the Q points in a transistor, if it is active region, it should be an active region. If the region is active, the transistor amplifier, it will take input signal faithfully. It will take a input signal faithfully. Coming to next is prevent deterioration. In this Q point will be shift towards the cutoff or saturation condition. The output, whatever output you will get, no, the waveforms get distorted. Okay. Then if you put properly Q point, will give a systematic output signal. Next will be and provide a maximum signal swing. Okay. So in the, if you keep the collector, if you keep the complete correct position Q points, if you keep the correct position Q point, which allows it will allow the output voltage very equally, whatever voltage will enter into that, it will equally distributed to both positive and negative direction. So you based on this result, the maximum undistorted output you will get. Okay, maximum undistorted output you will get. Next we have to go for improve the stability. So in the Q point, if you keep it stable, okay, if you keep it the stable, for example, any way changes in temperature or any transistor parameter, you can keep it the stable. Okay, next, if you stable bias, we can improve based on this, the stability of or stable of the amplifier, you can improve based on this. Okay. Next, coming to the effect improper Q point. If you not keep the properly, what will happen? So if you Q point near cutoff region, okay, near the cutoff region, what you will get? You will get a negative off cycle may be clipped and cause cutoff deterioration you will get. Same way, Q point near to the saturation region, so you will get a positive off cycle to be clipped. Okay, it causes saturation distortion. The next question is describe the working principle of N-channel JFET. So just coming working principle of N-channel JFET. First, before going to that, you should know the diagram. This is the diagram will give the N-channel JFET. Here is a dry terminals, gate terminals as given. Source of terminals P, N, P will be there. Okay. ID, current, resistor, voltage and voltage as given here. This is the diagram. They connected to ground. So you can write this diagram. Okay. After writing this diagram, so coming to the working principle, it is an N junction field effect transistor. It is a N junction field effect transistor. It is having a 3 terminals. It is having a 3 terminal which is connected to semiconductor device. Okay, it is current when current conduct due to majority charges. Okay, device which current conduct due to majority, it will carry the charges, that we call it as an electron. It is having a 3 terminals. One is an gate, one is an source and drain, SGSD. The construction, coming to the how it will be constructed, consisting of N type of semiconductor channel between the source and drain. It is there in the diagram, and it is having a heavy dropped P type of region. Okay, formed the side of the N channel and create a PN junction, that we call it as an gate. Coming to the working principle of that, so when the dry source voltage, if you applied, why dry drain source voltage if you applied. So if you applied the drain positive with applied drain source will be an positive with respect to the VDS, or electron flows through the source of drive, electron flowing through the drain to N channel. Okay, this will be produced dry current that we call it as an ID. In the gate reverse bias, here gate source junction will be a reverse, apply a negative voltage to the gate. So due to reverse bias, depletion region will be formed at the PN junction, okay, in the reverse bias. So next, coming to the control channel width, next will be a control channel width, how you are going to control. The negative gate voltage increases, the depletion layer widen. If the negative gate voltage increases, the depletion region will be wide. Based on this, reduce the width of the conducting channel, and a dry current will be decreases. Next will be a punch off condition. Sorry, next will pinch off condition. In that condition, some certain negative gate voltage, okay, depleted region will be touch each other. Okay, the channel very narrow, the channel will be a narrow, current become almost constant. That condition we call it as a pinch off. Next will be a cutoff region. Here cutoff region, if the gate voltage increases furtherly, okay, if increase furtherly, it will give negativity. The channel completely closed. Based on this, the dry current become 0. So this question is very important. So many times they may ask these questions. Discuss the advantages using a CE configuration over a CB configuration over a CC configuration. So here, what are the advantages of CE configuration over CB and CC configuration? Here CC nothing but common emitter configuration. Most we are going to use widely in the transition configuration for amplifier circuit, because it provide a good overall performance compared to common base, okay, common collector configuration. So what is an advantages of common emitter configuration? Coming to the high voltage gain in the common emitter configuration, which will provide high voltage amplification compared to common collector configuration. In high current gain, it will offers a considerable current gain, unlike common base configuration, which current gain will be less than 1. Same way, high power gain in the both voltage gain and current gain are high compared to common emitter configuration will give a high power gain. So it will suitable for audio and signal amplification you can use. And next will be a moderate input and output impedance. Common emitter configuration as a moderate input and output impedance make coupling input and output circuits are easier. Better overall performance of overall amplifier performance. So CE configuration will provide combination of voltage gain and current will give a power gain. So therefore the most preferred for configuration practically for amplifiers. But compare other configuration, compared to CB configuration, CE higher gain, higher current gain, higher power gain. Compared to CC configuration, CE higher voltage gain and power gain. Next, explain operation of CMOS inverter. It output when input voltage is high or low. Coming to the operation for a CMO inverter, it is a digital circuit made up of MOS FET. So it is consisting, one is PMOS transistor, one more is NMO transistor. So both will, if we drain the transistor, which will be connected together to form a output, the gates are connected together in the input. So coming to the working of COM inverter, it should be depending upon input voltage. When input low, PMO transistor is on, NMO transistor is off, and output connected to VDD through PMO. So finally we'll get a output is high voltage, high. When input high 1, so PMOS transistor is off, NMO transistor become on, output connected to ground through NMSO, output will get low. So coming to an advantage of a CMO transistor inverter, it is a very low power consumption and high noise humidity, high switching speed, compact size is high, a compact size and high reliability. So if the content is useful, please subscribe my channel, share and support. Thank you.